Hello everyone, welcome back to Leetcode Simplified. I'm Alan and today we're going to walk through Leetcode 145 binary tree Postorder Traversal. Given the root of a binary tree, return an array of all node values in Postorder sequence, that is left, right, root. We will solve this iteratively by simulating recursions using a stack. This helps avoid recursion limits on large trees and most importantly understand what's happening under the hood. Here is the trick. At first we traverse the whole tree in root right left order. Then at the end we reverse the result to left right root with the post order we want. Here is my two-phase process. Phase 1. Pop the stack point curve to the pop node, then append its value to the result array. Phase 2. If they exist, append left child first, then right child onto the stack. Repeat until the stack is empty. At the end, reverse the result array to get post order. Let's animate example 1 step by step. Given pointer root that points to node value 1 of a binary tree, 1, node, 2, 3. First thing first, append the root node value 1 onto the stack. Now we begin the two-phase process. Phase 1. Pop the stack, create pointer curve to point to the pop node value 1, then append value 1 to the result array. Phase 2. Node value 1 has no left child. Append right child node value 2 onto the stack. Repeat the process. Phase 1. Pop the stack, points curve to the pop node value 2, then append value 2 to the result. Phase 2. Append left child node value 3 onto the stack, no right child. Repeat the process. Phase 1. Pop the stack, points curve to the pop node value 3, then append value 3 to the result. Phase 2 won't happen because node value 3 has no children. The stack is now empty, no node to pop. Return array result reversed. All node values will be in post order. Let's move on to the second example. Given pointer root that points to node value 1 of a binary tree, 1, 2, 3, 4, 5, no, 8, no, 6, 7, and 9. First thing first, append the root node value 1 onto the stack. Now we begin the two-phase process. Phase 1. Pop the stack, create pointer curve to point to the pop node value 1 and append value 1 to the result. Phase 2. Append left child node value 2 and right child node value 3 onto the stack. Repeat the process. Phase 1. Pop the stack, point curve to the pop node value 3 and append value 3 to the result. Phase 2. Node value 3 has no left child. Append right child node value 8 onto the stack. Repeat the process. Phase 1. Pop the stack, point curve to the pop node value 8 and append value 8 to the result. Phase 2. Append left child node value 9 onto the stack, no right child. Repeat the process. Phase 1. Pop the stack, point curve to the pop node value 9 and append value 9 to the result. Skip phase 2 because node value 9 has no children. Repeat the process. Phase 1. Pop the stack, point curve to the pop node value 2 and append value 2 to the result. Phase 2. Append left child node value 4 and right child node value 5 onto the stack. Repeat the process. Phase 1. Pop the stack, point curve to the pop node value 5 and append value 5 to the result. Phase 2. Append left child node value 6 and right child node value 7 onto the stack. Repeat the process. Phase 1. Pop the stack point curve to the pop node value 7. Then append value 7 to the result. Skip phase 2 because node value 7 has no children. Repeat the process. Phase 1. Pop the stack point curve to the pop node value 6. Then append value 6 to the result. Skip phase 2 because node value 6 has no children. Repeat the process. Phase 1. Pop the stack, visit the pop node value 4, then append value 4 to the result array. Skip phase 2 because node value 4 has no children. The stack is now empty, so terminate the whole process. Right now, the result array contains values in root, right, left order. We will reverse the elements of the result from root, right, left to left, right, root, post order, the order we want. Alright, are you excited to make this happen? Let's jump right into Python. If no given root means no tree, no nodes, return empty array. Append the root node onto the stack and create empty arrays result to hold node values. Now begin the two-phase process until the stack is empty. In phase 1, pop the stack, then point curve to the pop node and append its value to the result. In phase 2, if left child exists, append it onto the stack. If right child exists, append it onto the stack. If the stack is empty, terminate the process. At this time, elements in the result array are in root, right, left. Reverse them to left, right, root. Here's easy tip for you to remember. Just make 2 tweaks to the pre-order algorithm to get this post-order algorithm. Tweak 1. Append the left child first. This gives you a root, right, left order. Tweak 2. Reverse root, right, left order to left, right, root, post order, the order that we want. I'm gonna sneak in one more look before submit. Oh, there's typo. Okay, we're supposed to append the root, not the stack. And left. Alright, code looks good. All the logic, all the coding, it all comes down to this. And now the moment we've been waiting for is time. Let's smart the submit button. Boom, accepted. And that's it. This solution runs in ON time, where N is the number of nodes, and use OH space, where H is the height of the tree due to the stack. This method is clean, recursion-free, and handle large trees without hitting stack limits. Understanding how to simulate recursion with a stack is a powerful skill in tree problems. If you're able to walk through this simulation step by step, you're building the foundation for tackling many more tree problems with confidence. If it helps, give it a like, leave a comment with any questions, and subscribe for more step-by-step Leetcode walkthroughs. I'm Alan and this is Leetcode Simplified. Thanks for watching. I'll see you in the next one.